record everything except like if you guys are doing something dead space. I should have recorded all that because that was actually a fun discussion. But I try to record much as I think is possible anyway, or as much as useful as possible. Cool. All right. Speaking of statistics and why we're here, what were we talking about last time? Remind me. I think it was Bert and Ernie.
Standard deviation.
Nice. I'm going to put some big measures of center. Arrow. Measures. I'm going to put an S on the end of this, of variation. What I want to do today is I really want to get into, I want to kind of nail down this variation idea. And I say nail it down, we're not going to feel perfect on it today, I guarantee that. It's going to go to those squirrely topics that's going to take a few weeks to really feel natural and comfortable, but you will, I guarantee that you will. I watch students get more and more comfortable with this as the terms go on. And by the time we get to the end of the term, and especially those of you that go to 244, it's just that constant exposure to variation. It's the kind of thing you're not used to dealing with in normal math classes. Because there is no variation. You factor a quadratic. X equals 3, and it's 3, and there's nothing else, it's 3. But yes, it could be something else. When he told you 50,000 students registered, that's incorrect. That's an estimate of how many registered. It's probably close to 50,000, but there's a plus or minus on there. I'm not trying to be a bastard, Marty. I'm not trying to be a jerk. But that's incorrect. It's not exactly 50,000. It's plus or minus something. So he gave you the average number that he thought had voted, or that you told him had voted. But there's definitely a plus or minus. He also told you that 2,000 were from COCC. False! On average, but there's a plus or minus on that 2,000 as well. So, I mean, it's one of those things that we don't get exposed to very much on a daily basis, especially watching the news. The news focuses on this and ignores this largely. Why? Why do we do that?
Give us more of a dramatic effect.
It can, it sure. Oh, thank you. Can we come back to that, Cassidy? I got some fun headlines that I love that. More of a dramatic effect. You can make a mountain out of a potential statistical molehill. Thank you. That's 100% correct. Why else? Why else? Although, now I don't want to say that like in a negative way. It might not be that they mean to be making or intentionally trying to make you think something jumped when it didn't. It could just be that they think it did. They could think that 8 to 9% is meaningful, when it might not be statistically. Pat, go ahead.
Well, either they don't know.
That, I think, is more true. This is something you learn very early on in your academic careers. The idea of an average or a median or a mode or say that or something like that. This, I'm guessing most of you learned the first time on Tuesday. Honestly, I'm guessing that that's exactly what happened. I think that you learned this for the first time 48 hours ago. So you've got, half your life behind you here, and you've got 2 days of your life behind you here. And most people never even get that. They only get this. So this idea of a center, or a median, or a mode, or a trim, even the trimmed mean, which I guarantee most of you hadn't even thought about before a couple weeks ago, that made perfect sense to you. Oh yeah, you throw the high and the low out, because you had been in classes where you throw out a low grade and load the high grade. Right? But then all of a sudden we come over to here, and we attach this guy. And you know what? I'm going to draw this arrow better. He technically only goes to him. We're not going to talk much about variation on these guys, and even these guys for the most part. You could, if you wanted to, you could do a trimmed standard deviation. But I want to focus mostly on standard deviation tied to the average. Do you know why? This is a bit of a bastard math question. I apologize in advance. Why are we only going to tie him to him, and not to say the median or something else, do you think?
Don't most people want to talk about
That's a good conversational reason, absolutely. But this is the one we mostly talk about. I'm as healthy as the average 30-year-old. I took my health risk assessment for my insurance company. They made me do this health risk assessment. You type in your cholesterol and your triglycerides. And I'm as healthy as the average 30-year-old. Whatever the hell that is, I'm as healthy as him. Yes! Please,
well,
Carmen.
the median and the mode don't account for what the actual values are.
Right. We used this guy to make him. He was a result of looking at distances away from this guy. Remember calculating Ernie's manually? We actually had to use this guy to calculate him, and the further away from average each thing got, the more the standard deviation got. Yeah, the median and the mode don't care about those individual values, those distances. So that's why we're going to tie him back to him. So you're going to see lots and lots, especially after today, this idea of x bar plus or minus these s's. Good. Other things you remember from last time? This is fantastic what you guys have put up with. Good so far? So I want to do a kind of a checklist. We had all these wonderful words that accompanied. Does that seem lower? No, it's captured. You can see it okay. Seems like it's down lower. I'm just dreaming. So here, center plus variation equals more than most Americans understand. That's what I've noticed. If you understand a margin of error, I mean, you go into any crowded department store, look to your left and look to your right, you understand more about centered variation or statistics than the person to your left and to your right do. I mean, honestly, you're in a minority, unfortunately, and we're going to try to change that over the next 10, 15, 20 years of education. But here's the big takeaways right now. So Cassidy, back to what you said about the whole idea of we're not exposed to it very much. There's a great website called Headlines from a Mathematically Literate World. I have a quote up there too, shouldn't I? So check out some of these. And they're adorable. And the more you understand statistics, the more you understand why these are funny. Okay, I put the website there for you if you want to go check it out. Heat wave seen as sign of global warming. Boom! I'm sure that you've heard this mentioned during our January. See? Global warming, global warming. Local heat wave not seen as meaningful indicator of a global trend. In other words, I'm not saying global warming does or doesn't exist. I'm saying be careful about using one point of data to overthrow an entire belief system. Just like right now, my East Coast friends see global warming, crap, total crap. Guys, look out here. I mean, look at our snowpack. You can't look at one localized data point and apply it to an entire planet. That's ignoring variation. That's ignoring variation. You see what I'm getting at? Totally ignoring variation. How many of you have been in a discussion where you say, I heard that you shouldn't smoke, you shouldn't smoke. Yeah, but I got this cousin. Yeah. Smoked 3 packs a day, lived till he was 85. A discussion like that? Yeah. That's ignoring an entire data set for want of one data point. I mean, it's a silly example, but you've heard something like it before, I'm sure. Okay. Psychologists tout surprising new findings. Okay? Oh my God, we just discovered smoking is good for you. In a mathematical literal world, psychologists promise to replicate surprising new findings before touting them. If you flip a coin long enough, it'll eventually come up tails 13 times in a row. Right? It's not going to happen very often. So before you start saying, oh my God, flipping a coin is not 50-50, prove to me that you can do that 13 times in a row more than once. You see what I'm getting at? Don't try to overthrow an entire data set based on one surprising result. And you'll study this more in Math 244. There's an article I just read called The Truth Wears Thin about how studies get overturned. And studies should get overturned, roughly 1 in 20 times. We'll study more about that why. We're going to start learning about that why today, and then we're going to really, really drive that nail deeper in 244. But you should overturn results, because sometimes new findings that are surprising are due to random chance fluctuations in a normal system. Right? Yeah. Oh, that was your foot. Okay. Also, the camera started doing like an ET thing. That's good. Unemployment rate jumps from 7.6% to 7.8%. Jumps. Now, I'm not saying 7.8% is not bigger than 7.6 because it is. But my problem is that 7.6% is not 7.6%. It's 7.6% plus or minus something. And so is the 7.8, plus or minus something. So a better way of looking at it is unemployment rate probably a little under 8%, maybe rising or not, can't really tell. What's going to sell papers? And all of these? The top one, the R world. That's why it's R world, because that's what you're reading in papers. As soon as you put it under the microscope of variation, you realize that there's a big with the logic, or lack thereof. Because in every one of these, and I encourage you to go to this, it's full of examples like this, every one of those ignores the basic premise of variation only to look at center. Okay. So here's right now, I want to get in more into the calculation and interpretation of this idea of variation. But right now, the sample standard deviation, we're going to call S. We're going to call S. Got to pair it with an average. Otherwise, it can't really tell you anything. You know? The deviation around Sean's exam score is plus or minus 5 points. Holy crap, he sucks. Yes, but his average was a 92. Holy crap, he's a genius. Right? So or plus or minus 5 points. Holy crap, he's a genius. Yes, but his average was a 10. Holy crap, he's a consistent anti-genius. You see what I'm getting at? I mean, you have to put the center in there because A, the center is used to calculate it, and B, otherwise you don't know where it's actually living. It's like getting a margin of error without giving the percentage in the middle. Plus or minus 3% on the study, yes, but how many people actually approve of Congress? I mean, plus or minus 3% doesn't tell you where the center is. You have to put the center in there. We already discovered this on Tuesday. You guys are one step ahead of us. Very, very nice. This was the whole point. This was the whole point. I know the formula was a little bit manky. The whole dividing by n minus 1 versus dividing by n. Some of you still feel a little bit nauseous about the squaring versus absolute value. I understand that. I understand that. Don't worry about that. You calculated your one and only standard deviation by hand with Ernie. From now on, we'll let the machines do it, and our job is to interpret what it means. More on that today. That's all we're going to do today, pretty much. When S is big versus when S is small. And I put those in quotes. You're going to tell me why momentarily. Big S's, scattered or varied data. Small S's, consistent data. What do I mean big and small? Why are they in quotes? Jolene, all relative. It's all relative. Big is only big when compared with something that's smaller than it. It's a yin-yang kind of thing. So the idea is, sometimes you can't say that something is big or small. Either number one, without more statistical information, or number two, without more practical information. I often talk in my 244 classes about the difference between statistical significance and practical significance. And there is a difference. Remember that headline, unemployment rate jumps from 7.6 to 7.8%? That might be statistically significant if the margin of error was no more than what? 1/10 of 1%. Now, I like that, Carly. 0.1 actually, right? 0.1%? Because if each of them has a 0.1 on them, 7.6 might go as high as 7.7, and 7.8 might come down to 7.7. 0.2, they'd actually overlie each other. Does that make sense?
Yeah.
So in order for them not to touch at all, no more than 0.1. So suppose the margin of error on the poll was 0.05%. Then you're like, well, yeah, 7.8 is meaningfully larger than 7.6. But only statistically meaningfully. Some people would say that's not meaningful in the grand scheme of unemployment. I can't argue that or not argue that because I don't know enough about how big a number has to be practically. We can only argue it statistically. More on that. There's homework questions and another quiz for you guys that deal with that more in depth. Please, Pat.
So I was writing.
No, go ahead.
I might have missed it. What defines big and small?
It's all relative, as Jolene said. Basically, you have to have more information somehow to know what big and small is. But the big idea, not big, not in quotes, the overriding idea is, as S gets bigger, it means your data is more scattered. And you're going to have explorations with this. I have a homework question that has an Excel spreadsheet attached to it that lets you vary data points, and it shows you how S changes as you vary the data points. So it's more of a dispersion measure than a comparer. Comparator, something like that. Yeah, fair enough? All right, good. I want to take 5 momentarily, but before we do that, I want to exit out of here real quick. And I do want to collect a little bit of data. And I want to take a look at this at the break and see if we can play with it in class. I think we can today. I made this spreadsheet last night, early this morning. I threw some random numbers in here, so let me clear these out of here. I want to get your guys' heights. So just, unless you don't want to give them to me. I mean, it's only to look at data and see if any trends arise, that's all. So let's just go 4.6. I took guesses as to what the small should be. 4.7? Anybody under 5? Under 5? Okay, so we can start at 5. 5.0, 5.0, 5 feet, 0 inches, 5.1. 5.1? Okay, we got 2 5.1s.
Me too.
You got 3?
Yeah.
3. And I just erased my formula. Hang on one second, guys. I gotta do this real quick. Equals this plus this, because I'm keeping track of also a. There we go. All right, 5.2. 5.2. 1, 2, 3. Oh, 5.2. 5.2.5. We'll call you 5.3, Cassie. 5.3. Yes. I'll call you 2, 4. Good. 5.4. 5.4. 1, 2, 3. 5.5. 1, 2, 3.
Oh no, I was saying how I fluctuate.
Oh, how you fluctuate? Well, it depends what time of day you measure yourself, right? Gravity wins after a while. So far, all the females raise their hands.
Okay.
So, 5.6. I'm also keeping track of both together over here to see if there's any kind of trend. 5.7. 1, 2, got 1 each. Yeah. 5.8. 1, 2, 5'9". This might be too small to play with, which is what I was kind of afraid of. 5'10". 5'11". That's me, I'm in there. Actually, I round to 6. I call myself 6. 6! 5'11 and a half, especially early in the morning. 6'1". 6'2". Anybody else? Anybody else I haven't accounted for?
Put 5'10" for me.
Put a 5'10" for you, Ryan? Absolutely. I don't think this is going to be noisy enough for us to play with, unfortunately. Let me take a quick look. So here, over here, yeah, well, ish. We can try it later. I brought some backup data just in case this didn't work. So, yeah, we'll mess with it. We'll see if it holds up with our small data set. Let's take 5. Let's take 5. You'll know what the hell I'm talking about 15 minutes. This will actually make sense. Oh, it's okay. It's okay, Carla. Don't you worry about it.
Thanks.
Not to worry.